Hello everyone and welcome back to this new session of the Atos Smart Tutorial. Today we're going to speak about access controller and more specifically about the technology and the characteristic of the position transducer that can be paired with this category of product. An access controller is an electronic device that manages and controls the position of a linear or rotary hydraulic actuator that moves a specific part of the machine. These devices use the feedback from a position transducer installed on the actuator to control with high accuracy the position of an axis or a motor, acting on the spool opening of a proportional valve. However, there are several typologies of position transducer available on the market nowadays: analog, SSI, encoder, field bus, IO-link. But what are the differences and which one should be selected? Let's analyze together some of these categories and let's have a look at the main characteristic of a position transducer. A position transducer is an electronic equipment used to measure the position of an object or a moving part within a mechanical or automated system. It is employed to convert the physical quantity, such as distance or angle, into an electronic signal that can be used by the control system. The main parameters of a position transducer are the measuring range, selectable by the user and based on the mechanical stroke of the cylinder. The mounting type, external or internal. Built-in solutions are the most recommended as they are not subjected to mechanical displacement due to mechanical shocks or vibration on the machinery. The type of measure, absolute or incremental, we will explore this aspect shortly, and then the output type, SSI, analog, incremental TTL, IO-link field bus are just some of the interfaces available on the market. Other very important parameters of a position transducer are the linearity error, intended as the difference between the ideal and the real response measured by the device, and the resolution, intended as the minimum variation in quantity that our device is able to detect, a very important parameter to define accuracy and repeatability of the positioning system. There are also several technologies to convert the physical quantity into the electrical signal. The most common and widely used are magnetostrictive and optical scales. This last technology is not really recommended an industrial application, since typically requires a specific zeroing procedure at every machine startup, and normally are not available for built-in solution. Potentiometer and inductive sensor are not recommended for a high-performance closed-loop system, as the Atos one. Now, let's see at which type of position transducer can be interfaced with Atos axis controllers. Having excluded optical, inductive, and potentiometer sensor for the technical reasons explained earlier, today we will focus on the magnetostrictive technology, which can have either analog or digital output. Basically, despite the transducer technology, Atos axis controller can be interfaced with two feedback output signals. Analog output, either in voltage, 0.10 volts, 0.5 volts, or current, 420 milliamps, and digital output, for instance, SSI or encoder. Position transducer with field bus, IO-link, or other communication protocols are not compatible with Atos axis controller, as the Atos axis controller cannot be intended as a master device, but instead must be considered as a slave device within the network, just like the position transducer. Voltage analog transducers are used for short wiring runs, where the voltage drop does not affect the feedback signal. For cable length greater than 20 meters, we recommend use 420 milliamps analog feedback transducer. Additionally, one advantage of the 420 milliamps range is that allows detecting potential cable broken condition and ensure safety on the system. Atos, as a rule of thumb, generally advised against using analog transducer for actuators with a mechanical stroke greater than 100 mm. This is because the resolution of an analog transducer is inversely proportional to the measured stroke, and very large strokes will negatively impact the resolution, making it difficult to achieve good positioning performance. For example, considering the characteristic of the analog inputs of our axis controller and the nominal stroke of hydraulic actuator of 100 and 500 mm, the respective resolution would be 4 micron for a stroke of 100 mm and 20 micron for a hypothetic nominal stroke of 500 mm. But these are theoretical data. On the field, we know that the electrical noise, this data could be higher, as shown in the table. A lower resolution will make it difficult to achieve good performances in positioning. In fact, the maximum accuracy of the system is generally, theoretical point of view, estimated using an order of magnitude above the resolution of the transducer. Analog position transducers are also more sensitive to noise from other devices, such as electrical motor and inverters, which can negatively impact the quality of the measured feedback signal, compromising the accuracy of positioning. Let's now move to the digital output interface transducer. A transducer with SSI output will always provide the exact position in absolute term, regardless the zeroing position or the power state of the device. On the other hand, an incremental encoder measures only the changes in position relative to a reference point or zero. The initial zero or origin point must always be set each time the axis controller is powered on, through a specific dedicated procedure called referencing. Being an absolute transducer, this procedure is not necessary for the SSI output transducer. For both SSI and encoders, the resolution data is a fixed parameter and does not vary with the nominal stroke of the transducer. Typically, the resolution is a selectable parameter by the user and can be very high, allowing for greater positioning accuracy. Since both SSI and encoders are digital interface, they are not sensitive to electrical noise, ensuring that the quality of the feedback remains very high, even in very harsh industrial environments. This also translates into better position control performance. But now let's have a look together at a practical example, consisting of an Atos servo proportional valve with integrated axis controller and a servo cylinder, initially equipped with analog position transducer. And then we will modify this setup by replacing the analog output with a digital SSI transducer, where we could appreciate the difference between the two different typology of output signal. First, it should be noted that the auto-tune procedure, which is the automatic position PID optimization procedure present by default on all Atos axis controller, will estimate a lower KP, proportional gain, for the setup with the analog transducer compared to the setup with the digital output transducer. This is because, as mentioned earlier, the digital transducer provides a more stable and precise feedback, allowing the controller to use higher PID gains for better performances, while the analog transducer may have limitation due to the noise sensitivity and resolution, requiring a more conservative tuning. In fact, by increasing the value of this gain, the risk is to introduce vibration during the movement of the axis. As a result, the positioning performance will be lower, with a slightly more unstable position entry and a slight overshoot, as you can observe from the instrument reading shown in the video. If now we move to the two acquisitions sampled by our axis controller, we can also notice how the analog feedback signal is, in fact, identified by higher noise if compared to the digital one. And using the zoom function of our oscilloscope, we can observe that the positioning error in the setup with the digital transducer is lower compared to the one with the analog transducer. Obviously, it always depends on your performance level requirement, but we strongly suggest magnetostrictive with digital SSI output transducer, as this choice allows you to achieve higher position accuracy and save valuable time during the commissioning phase, avoiding several wiring optimization and fine-tuning operation on your system. However, the compatibility of the digital transducer with Atos axis controller must be always carefully evaluated by our team of specialized technicians, who will be able to guide you toward the best solution for your application. Thank you for joining today and see you in the next Atos Smart tutorial.